Thanks for joining, everyone. So today for SE Office Hours, we're talking about getting AWS data into Logstream and then doing some fun stuff with it. And I've got some examples prepared for packs and pipelines and all the good stuff there. So with that, our agenda for today, talk about the services, the AWS services that are supported by Cribl Logstream, how to get those services and sources to Logstream, and then what can we do with them. So without further ado, what do we support? So there are a few sources in Logstream that we support, both from a pull and a push perspective. Pull is pretty commonly used to go collect data out of S3 buckets. S3 is also supported from a push perspective. So you might say, well, why would I choose one of these over another? So there are some scenarios where customers don't actually have full control of the S3 bucket. In this case, a great example is Cisco Umbrella logs. So if I'm using the Cisco managed bucket, I do not have the ability to add event notifications into that bucket and receive notifications when there's new objects inside there. So I have to use a collector to go scrape the data on a scheduled interval. Both of the S3 functionality works effectively the same way, but basically it's who's originating the, what do you want to call it? Who's going to jump first? Is it us or is it Amazon? So we go and collect the data using the collector, and Amazon tells us, hey, there's a new file with the push-based service. So we'll talk a little bit more about that in a second here. There's also two more services here related to each other, Kinesis and Kinesis Data Firehose. Similar services, do stuff slightly differently. We'll talk a little bit more about those in a minute here. And then there's also SQS, or Simple Queuing Service. So with that, let's talk about what these services are. I always have to remind myself, not everybody knows what these mean. So I'm going to step back here and recalibrate real quick on this. So S3 stands for the Simple Storage Service. Basically, this is an object storage platform. You can put any data in the cloud. I mean, any data. It could be text. It could be binary. It could be a picture. It could be a movie. It could be a tarball, a gzip tarball, whatever. It doesn't matter. An object storage platform is built to take basically a prefix and a file name and associate it with binary data inside cloud. So I can put my logs into object storage, and that's a great way to handle that because S3 is highly durable. I think it's like 7 or 9 nines in terms of durability. Like a millennia will go by before a file is going to be lost inside S3. And then it is infinitely scalable. There is no upper limit on the size of an S3 bucket. As long as your partitioning structure and file names are unique, you can put unlimited files and unlimited amount of data into that S3 bucket. What's also great about S3 is you can tier your data. So tiering allows for that flexibility of cost and what storage medium is used. By default, S3 uses the quote unquote standard tier. And moving down below that, you have tiers like infrequent access, which means I'm not going to be accessing this data as frequently. I need to keep it immediately available, but maybe I only want to have it in one zone instead of multiple zones. Maybe I am moving this data to be archived. I can use something like Glacier. Glacier is think of it as dehydrated data. The metadata about the file stays in S3. So you can still see on your file system, hey, I have all these files, but the data lives somewhere else. It used to be on tape. Amazon has changed how that architecture works. So, it's slightly different now. but it does cost you to retrieve that data, and it is not immediately retrievable. And then there's even further below that, Deep Glacier, which takes even longer, up to 24 hours to retrieve that data, depending on where you store it and how quickly you want to get it back. But as the availability decreases, the cost also decreases too. So yeah, thanks, David, putting in the chat here. S3 is durable, offering 11 nines, designed for data durability and keeps data safe, even if entire Amazon building is lost. Secure, highly available, and basically everybody uses S3 with AWS. So back to the point I was just making, standard tier is going to cost you 2.3 cents per gigabyte. But if you move objects to Deep Glacier storage class, those cost, I think it's like 0.09 cents per gigabyte. So the cost drops off significantly for storing this data. You are charged for that metadata that's stored at standard class price, but that's like 128 kilobytes versus you could have a gigabyte file in Deep Glacier. So it's probably more in S3 than you needed to explain. But
Brandon, quick question on S3. Do we, for our S3 collector, do we care what tier the S3 bucket is in, or can we collect from any like Deep Glacier or whatever? Does it matter?
That is a great question. So we do not support collecting from Glacier or Deep Glacier classes because we would have to make an additional API call to rehydrate that data and wait for it to be available. So basically anything from standard access, infrequent one zone. I think there's a few others, but basically anything that's not Glacier class is supported. However, if you are retrieving data from like an infrequent access or other tier, you're going to incur a data retrieval fee. So this is where you can build in things like lifecycle policies to S3 to say 90 days, keep it in standard. After 90 days, roll it to infrequent access for 180 days. And then after that, maybe 365 days, roll it to Glacier class. And then after 3 years, expire the data and delete it from my bucket. So there are ways of handling that. So it goes back to, how much you're going to be accessing that data. Do you need it all the time? Do you not really need it all the time? What's the cost trade-off between retrieving it and storing it? So many things to consider. For instance, I was on with a prospective customer yesterday, and they were talking about, hey, we're going to archive this data. We don't plan to retrieve it using replay pretty much ever. But if there is a security incident, we'll go rehydrate this data. So it's like, great, move it right to Glacier class and don't have to worry about it. But for folks that want to leverage kind of that forking of data, I want to put archived copy in S3, and I only want to send a smaller subset of that data to the analytics platform or APM platform. Keep that in something like standard class if you do need to go retrieve it really quick for a short period of time. So that was a long-winded answer, but I think that was what you were looking for, Kyle.
Yeah, thank you. Actually, that sort of brought up a new question. So we can send it directly to Glacier, just collecting it back would, okay, perfect.
That's correct. Yeah, in the destination inside Logstream, you can actually configure the destination to use which class you would prefer. So you can set it up to go directly to Glacier if you want. But yes, that would mean that you can't go back and do a retrieval of that data using replay unless you manually intervened and told S3, hey, pull this data back. And then you have to wait for it to be available.
Got it. Cool.
Awesome. All right. Yeah, feel free to stop me at any point. You got questions, throw it in the chat, raise your hand, shout over me. Don't really care. So I'm here to help you guys on this. So let's talk about SQS for a minute. So SQS stands for Simple Queuing Service. And if you want to think of a direct equivalent, it is very, very similar to Kafka, where you have topics or queues in this case, and you can fan out queues to multiple consumers. So a producer will write data into a topic or queue, and then a consumer will read data off that queue, or I can have multiple consuming queues. So basically, I can take one notification and send it to multiple systems, depending on what's going on here. The nice thing about SQS is it really supports any type of data. I can send raw data. I could send JSON formatted data. I could send binary data over SQS. And that consuming system will then process it basically whenever it pulls from SQS. So typically, this is used for decoupling applications, so middle tier, back end, that type of stuff to make processing asynchronous for applications. In this case here, we can leverage SQS to receive or forward data. But typically, when you're going to be working with SQS, it's actually in conjunction with S3 as event notifications. I'll touch on that a little bit more here later. So very simple mechanism to move data quickly between systems. Now, SQS is great to an extent, but if I need to pump gigabytes per second of data through to other systems, I would look at using something like Kinesis, or the full term, Kinesis data streams. So again, streaming data service here. You are responsible for building out the number of shards that are required for your Kinesis data stream. So shards are able to handle about 2 megabytes per second of throughput, and you're charged per shard on a daily basis. You're not charged for the actual amount of data that's pushed through. So you have to scale this depending on how much data is going through, and you have to monitor. What's nice about these data streams here is you can store the data in flight. The default is 24 hours, but you can move this up to 7 days if you want to retain that data. So let's say Logstream is restarting and unable to retrieve the data for a little period of time, or you're upgrading with 3.2 that just came out. Hey, I'm upgrading. I'm going to take Logstream offline. Kinesis will spool that data for you, and then you just basically pick up where you left off. And that's the last point here. You can replay the data from the last timestamp that you retrieved. So Amazon will handle that for you. You can start basically, it's like pausing a TV show. You just pick up where you left off. It knows exactly where that timestamp is and starts playing from there. So that's nice, but it's a little, cumbersome for folks to do this in terms of getting the data over to systems. So usually see what's called Firehose, Kinesis Data Firehose, or I'll refer to it as KDF in the presentation here. Kinesis Data Firehose is a streaming service. It does not store this data. It is responsible for basically taking the data from one location and piping it over to the destination. And Firehose supports many different destinations, could be to an S3 bucket. And this is actually typical for, I need to take all of my CloudWatch logs or CloudTrail logs. And Kinesis Data Firehose is one of the very few mechanisms supported of moving that data to an S3 bucket. So you could stream it directly, or you could put it in S3. Data Firehose also supports, Amazon managed services like Redshift, the OpenSearch, or formerly known as Elasticsearch service. But Splunk is also on here, so we can send this data via HTTP out to a receiving system. This is auto scaling, so you don't have to worry about scaling it up, scaling it down. You do pay for this though dearly. It is an expensive service, but Amazon handles all of the back end for you. You just send the data, and it forwards it off to the destination. We support receiving this data either via the generic HTTP. So that tile that you saw that says Firehose, that's a generic HTTP destination from Kinesis Data Firehose. We also support Splunk HEC as an output from Firehose. So you could choose Splunk as a destination and use Splunk HEC as a receiving mechanism inside Logstream. This is fire and forget, and it will retry. It's kind of like an exponential back off. If it can't write, it'll back off for a little bit. It'll try again. If it can't, it'll fail a couple times before it will put the data into an S3 bucket. And then you can use a collector, believe it or not, to go pull that data back if it does not successfully send. So Firehose in a nutshell here. I'll pause for a quick second, because otherwise we're going to talk about how this works. So cool. Source setup. And I'm not really going to walk through this in the UI. I'm going to talk more conceptually about this here. You go read the docs on docs.cribl.io if you want to see more about this. But just kind of conceptually, here's how this is going to go. So S3. You're probably going to spend a lot of your time setting up S3 in terms of a push source. So you do need to set up event notifications on the bucket, and typically that is for all put requests. So when a new file is written to the bucket, what will happen is it will send a notification to an SQS queue, and that queue holds the messages that Logstream will pull. It'll go say, hey, are there any new messages in this SQS queue? And if there are, it will retrieve that. It's in a standard format. We will then know which files are new inside the S3 bucket and only retrieve those. And that's distributed across all the workers in that worker group. Now, I did want to put on here the little caution. Don't confuse the S3 push source with SQS. If you choose SQS as your source, you're going to be very disappointed with the data that you see inside Logstream. You'll actually see the raw event notifications for the S3 bucket and not the data that's written to the S3 bucket. So make sure when you're setting this up not to confuse the two. You want to use the S3 push source. And I actually, let me go over to the UI here. So when you're setting this up, you got this here. No, that's the collector. That's not what I want. When you're setting up the S3 bucket as a new input, you'll notice there is no bucket name for the push source. It actually asks for the queue name. So we automatically will know which bucket we have to pull the data from based on the event notification that is received on the SQS queue. So just something to note here on that. So pretty simple to set this up. Let's see here. You need to have IAM access, identity and access management, granted the items below on your screen that you can see here. So you need to be able to have these permissions on the bucket itself and then the queue. So if you have those permissions, that is the least permissions that are required for Logstream to work correctly, you'll be able to retrieve that data. I did make a note that if you are using KMS encryption, whether that's S3 managed or that is customer managed KMS key side Amazon, you also need the ability to decrypt the data on Amazon. So there's a small call out in a couple slides here that I'll talk about that. This is kind of a gotcha that I see people running into quite frequently with, hey, the data is encrypted. I've given it least permissions, but I'm unable to retrieve that data. It's usually, hey, you need to have access to the key itself to retrieve that data. So that's S3 setting up in a nutshell, not super difficult. So SQS is even easier. Again, you can send any type of data over this. So we'll do the event breaking on that. Workers pull for messages on an interval. I actually don't know what that interval is. It may be once a second, every 5 seconds, something like that. It's pretty quick. I know there's an enhancement request in to be able to change the period that the data is being pulled out of SQS. So you notice that the permissions here are pretty similar to the previous S3 slide. The only item below here you'll notice is the create queue is optional. You don't have to do that. Inside Logstream, you have the ability to actually have Logstream create that queue for you if you want. So as an SQS source, when you set this up here, you notice that there is a checkbox that will allow you to create a queue if you want that. Most folks don't want that, just to keep permissions to a minimum required. So again, this looks very similar to the S3 screen: queue, region, input ID, etc. All right, kinesis. So kinesis is a bit complicated here when it comes to handling inside Logstream. And I've actually extracted out one of the architecture diagrams here, and I want to talk to how this works. So you enter the stream name and whether or not to start from the earliest or latest record when this starts up here. So if I add a new kinesis source, you'll see here's the stream name, and then the shard iterator start. Where are we going to start? Are we going to backfill all the way from the beginning of the data inside the stream, or are we going to start at the latest record that's inside that stream? And then obviously the region that is hosting this stream here. So with that too, there is actually some data that's persisted on the leader itself. I won't bore you with all of the details on that, but that is the last record and the shard info per worker process. So on an interval, what happens is you'll see the leader or the workers themselves will actually shuffle or rebalance the shards that are being read from inside the worker group. So typically, this doesn't incur any changes if there are no additions or deletions from the number of workers inside your worker group. Now, if you add a new worker out at that interval, the shards will be shuffled across there and rebalanced. And then on that interval too, each worker process will report back to, in this case, it says master here. This is an old architectural diagram. It'll report back to the leader node and say, I am worker process so-and-so. I have these shards, and this is the last place that I read from. So that data is then persisted to the state directory on the leader itself. So there is some state that is required to be maintained on that leader. So if you are reading using Kinesis data streams, it's very important not only to back up the config on the leader using the Git repo, but actually back up the state directory in addition. Otherwise, if the leader blows up and you restore it, you will be back reading from wherever it thinks you should start. In this case, if there is no state, it will be the default config here. So where do we start? The earliest or the latest? So that's where that decision is made if there is no state data that's stored on the leader itself. So just something to keep in mind as folks use Kinesis data streams here. Great item in the chat, Paul, SQS long polling. And yes, it does help keep the costs low. Basically, you're asking, hey, Amazon, do you have anything new? And actually we'll keep that HTTP connection open until there's new data. So instead of asking and closing every single time until there's something new, it'll just basically more or less hang that session open until there's new data. So yeah, that's great. We do have a ticket open on that. Cool. And then permissions for IAM, minimum required, get records, get shard iterator, and list shards. So with that, Kinesis data firehose or KDF. This is this is a fire hose of data, quite literally. There are some architectural considerations here when you build this out. There are some gotchas, and I want to point them out. If I can figure out where's my highlighter. Mirror, where are you? Whatever. So you need a classic load balancer, not an application load balancer, not a network load balancer. So today, Cribl Cloud technically does not support Kinesis data firehose. And you also need to have your load balancer installed with a certificate that's signed by a trusted certificate authority that Amazon trusts inside the Kinesis Data Firehose service. Those are listed on their documentation. You can go find those there. This is something that I typically see. The second one here, this is usually the issue that I run into. Either there's an invalid cert or self-signed cert installed on that load balancer if you're not using Amazon to receive that data. And again, you can use a generic HTTP destination, or you can use Splunk as a destination, which will then use Splunk HEC on the log stream side, and then configure your destination appropriately in the Firehose config. So pretty simple. Typically, you'll see a Firehose hooked up to a Kinesis data stream. It just makes it really easy to forward that data over to a consuming system. So it's pushed instead of pulled out of there. And Amazon will then keep track of all of the states and shards and all of that for you. You don't have to worry about it. So this is stateless. You just have to pick up the data that doesn't make it, that gets dropped in that S3 dead letter bucket. So call out here on KMS Decryption. So this applies to all of the AWS. So S3, SQS, Kinesis, and Kinesis Data Firehose. If you are encrypting that data, and this is specifically talking about customer managed or even Amazon managed keys, you will need to have the ability to decrypt that data. Now, it seems kind of counterintuitive, but it's actually not decrypting the data. You need to be able to decrypt the KMS key, which then the KMS key provides the encryption keys that give you access to decrypt the data. It's kind of a two-step process here. You get the key, you can then decrypt the key, and then you get the key material, which then allows you to decrypt the data that's encrypted by KMS. So typically what you'll see, if you have an error, it says, hey, you're not allowed to decrypt. More than likely, that data is encrypted by KMS, and you do not have permission to work with it, whether that's S3, SQS, Kinesis, or Kinesis Data Firehose. So adding the action here, KMS Decrypt, allow for that specific key, will grant you the permissions to be able to decrypt the data, and you won't run into this issue. There is a consideration too on the SQS side for S3 specifically. If you're setting up event notifications, you will also have to grant the S3 principal the ability to decrypt and generate key material for KMS to be able to write events from S3 into SQS. So just also something to consider if you have encryption turned on there. Cool. So that is setting up that in a nutshell. Let's talk about use cases here. I've got a few examples. Unless there's questions, I'm happy to pause for a minute and answer questions. All right. So some sample use cases that I have here. I've got two packs that Cam Amir, our VP of Business Development, has built. And I've actually changed them slightly just to show some additional examples here. In this case, I'm going to take some VPC Flow logs and do some interesting things with them. Filtering especially important because there is a lot of data coming out of VPC Flow logs, and not all of them have as much value as others do. And then doing things like converting them to metrics. So instead of logging, in this case, Splunk specifically, if I wanted to take these events and instead of storing them as event data, I can store them as metrics. So we use the publish metrics function to convert the actual events themselves into metrics, which you can use to store inside a metrics index. Alternately, you could look at leveraging the aggregation function, and the aggregation function would allow you to roll up VPC Flow logs because those are typically in 60-second intervals that you're receiving. So you could then aggregate them into longer spans and have different statistical functions applied to those events. And then applying things like threat intelligence to your data. Kind of going back to the filtering discussion, let me see if there's anything bad going on in my account or accounts. And then CloudTrail, similar idea, reduction of logs that are coming in. CloudTrail will literally show you every single API call that you make inside console. Listing the home page fires off about 50 different API requests to get information that's inside AWS. A lot of that is noise that, for instance, security teams, I really don't need to know that people are accessing read API operations. I only want to see when something's changed. So get, list, or read, those type of describe, those type of API operations. Don't really care about those. But what about the set, update, change, create, those type of operation? I really want to see those so we can use the pipelines to filter out the noise. So let's take a look here, kind of going in backwards order. So I just pulled in some sample data here and playing around with this. So typically when you have CloudTrail coming in, this will be JSON data. You'll have multiple records inside a file, and you can use the array event breaker, JSON array event breaker, to unroll those events. And you can have individual events here. So you don't have to do this in your pipeline. And then that data is already parsed. But in this case here, we're using the parser to extract out that JSON object. So all the goodness too, being able to remove fields that aren't interesting, also filter out, like we talk about all the time, filtering out null values. So clean those up. And then like I was talking about earlier, the describe and list and get type requests. You can see inside here the event name itself. That's the actual API command that was issued. So things like get bucket location. Where is this bucket located? Is it US West 1, US West 2? I don't really care. But hey, I started logging on CloudTrail. I'm interested in that. So this drop function here, just a very simple example, being able to reduce down the noise of the events that aren't interesting. There we go. That event is dropped for get location, but the start logging event is passed along, and then we can send this data back out in JSON format with all the fields extracted and all that good stuff. So this is a very, very simple example of handling this, but this will definitely cut down on a lot of the noise that's coming out of the CloudTrail logs, especially if you're looking to burn down that haystack and find the interesting or unique events inside your console. Now, you could also look for other things inside these events, like where's it coming from, any of the user identity, that's in here too. So you could look for like assumed roles, you could look for cross account access, you could look for, who's doing stuff in my accounts here. And that all that data is here inside that identity information, but maybe it's not useful to have all that here. So you could distill this data down and reduce the volume of data that's being forwarded over. So the one that's a little bit more interesting here is VPC Flow logs. So let me turn all of these off here. And I have this set up where I've got VPC Flow log data coming in. This is just sample data. So typically this is what an event will look like here. It will have a version number. 2 is pretty typical. 3 and 4 and 5 are also available. They're longer logs that contain more information, but just for simplicity's sake, that's what's here. You will have an account number at the beginning of these events. And this is always the fun part about VPC Flow logs is if you're looking for timestamps, usually this is the first number that's picked up on because it's a 10-digit number. It looks like a timestamp. So usually get it wrong. This field here, further in the event, that's the actual timestamp of the event. So the event breakers that are built into Logstream handle that for you. So you don't have to worry about that. But if you are working with a customer, make sure you do go and add that event breaker to your data source. So those are here. And you can see that AWS rule set. flow logs, and here's that timestamp anchor. So just keep that in mind as you're working with AWS sources here. So this data comes in, we're going to parse it. You could use the header-based event breaker, or you could use the event breaker that's built in. But in this case here, I'm just using the parser function and filtering any null values. So here we have all of our fields. It's nice, pretty simple. You will get data from VPC Flow logs where there are times where it says no data, or it actually skips the collection of that data and will populate it in a future flow log. So we want to drop those. You can see I've already dropped 2 events here because they don't have any data associated with them. And then my next function here that I'm doing, so talking about flows that are allowed in my environment. So most folks are pretty permissive when it comes to just creating security groups and allowing EC2 instances or containers to talk to the internet or talk to other systems. So, I come from a security background. I'm always interested in this type of threat modeling where, I know which flows are approved, which systems should be talking to which systems. Maybe you want to even go further to which systems and which ports are allowed. So in this case here, I built a very simple CSV file that has some subnets in them. And in this case here, I said, 172.31/16 is allowed to talk to 172.31/16. Again, very simple example, but Logstream will allow you to be able to populate this file with much more complex data to be able to filter out data that is allowed inside your environment. Again, back to bird in the haystack. What is allowed? I want to get to what is not allowed and see those logs. Those are interesting. You find which tab I was on. And you'll notice I'm actually not using the lookup function. I'm using the internal Cribl CDOT functions here. So CIDR lookup against my file. And I'm using the source address column matching against the source address field. Same thing with the destination address field. So in this case here, if both of these match, I am dropping the event. So you can see here, this first event, destination address and source address 172.31/16, those match, and we'll drop that event. Now, maybe I have some threat intelligence. Some of you should recognize this from the demo here, but if I want to throw some rudimentary threat intelligence in here, known bad IPs or threat actors that shouldn't be talking to my system, I can do that here. In this case, I've thrown in a very simple, in this case here, 192.168.1.200 is listed as a compromised IP. So I'm matching this against the lookup file there. In this case, we were able to output compromised true, but in this case here, this specific event at the bottom does not have compromised here. But this event is allowed through because if you notice, the source address does not match the 172.16 or 172.31/16, excuse me. So this would be an event that would be passed on to the receiving system. And then you can always clean up these events here, pass those on. So just in the sample set here, the events that we took in, we're able to whittle this down to 2 events from the 6, and then also reduce the overall size of the data going out. So just some examples on this. Would love to hear use cases folks are hearing out in the field, stuff that's interesting, stuff that we should be doing.
That was great, Brendan. And any questions, comments, use cases? Quiet crowd today. All right. Well, we appreciate your time. We've got Ed Bailey, who popped in there for a minute on December 1st, and he's going to cover deployment architectures. So join us in 2 weeks for that. And I'll stop recording right now. But we appreciate it, Brendan. That was great.